Students, today we are going to discuss about alkyne production methods and reactions of alkynes. Method of production of alkynes in your syllabus is elimination of bromine from a dibromide. So in here, according to the Saint-Ives rule, bromine goes with the hydrogen of adjacent carbon. So here this bromine leaves with this hydrogen and this bromine leaves with this hydrogen, making two bonds here more than the existing bond. So a triple bond is formed. The reason that we should use for the elimination is alcoholic KOH, potassium hydroxide. So by using alcoholic KOH, we can eliminate the bromine in a dibromide and make an alkyne. Now we can discuss about the reactions of alkynes. First of all, we will discuss about reactions with hydrogen halides. So here basically we are going to discuss about three hydrogen halides: HCl, HBr and HI. So when you add a hydrogen halide to a triple bond, what happens is this alkyne turns into alkyl halide. Alkyne turns into alkyl halide. So here in this reaction you can see addition of HCl and here you can see addition of HBr. So what happens here is when you add HClOHBr to the same carbon, 2 bromine or 2 chlorine or 2 iodine adds. This happens because of this. Here when you add HBr for this, one bond breaks and forms CH3, C double bond CH. So from these two carbons, the carbon with more hydrogen is this. So hydrogen joins to this one and bromine joins to this one. So in the next step what happens is this bond breaks and for this bond a bromine and hydrogen joins to this alkene. So hydrogen goes to the place where with more hydrogen according to Markovnikov's rule and bromine goes to the carbon with less number of hydrogen. So in that way, if we want to add two halogen atoms to same carbon, we have to put hydrogen halide to alkyne. So here HCl addition is shown from this one and HBr addition is shown from this one. This molecule is condensed and written like this. If I expand this one, this will be like this: C, C and C. For the middle carbon, 2 bromine and hydrogen like this. So in organic conversions, we can write this carbon and 3 hydrogen together as a CH3R group. And here also carbon and 3 hydrogen CH3. So we can condense and write these organic compounds, so it is easy for us to write. Then we will discuss about the reactions of alkynes with hydrogen halides with the presence of peroxide. So the peroxide we are taking here is ROOR, or else we can take H2O2. So what happens in a peroxide medium is, to HBr, if we put HBr in peroxide medium, it undergoes the anti-Markovnikov's rule. According to Markovnikov's rule, hydrogen goes to the place where with more hydrogen, but when you put HBr in the peroxide medium, what happens is hydrogen goes to the carbon with less number of hydrogen. And I highlighted you the point that there is no change in the reaction when you add a peroxide to HClOHi, right? I have discussed about this in alkene video also. So here this is the addition of HBr in peroxide medium, and this is the addition of HCl in the peroxide medium. So when we take this HBr addition in peroxide medium, you can see that one bond breaks and HBr adds. Hydrogen goes to the carbon with less number of hydrogen, and bromine goes to the carbon with high number of hydrogen. And then again this bond breaks and hydrogen goes to the place where with more hydrogen, and bromine goes to the place where with less hydrogen. So here now this is symmetric, right? This carbon has also one hydrogen, this carbon also have one hydrogen. But you should remember the point that when you add hydrogen halide to an alkyne, halogen atom goes to the same carbon. So considering that point, I am going to put Br here and hydrogen here. There is only effect with HBr to peroxide. No effect to HCl. HCl behaves only according to Markovnikov's rule. So hydrogen goes to the place where with more hydrogen. Chlorine goes to the place where with less number of hydrogen. So when you add halogen to an alkyne, what happens is alkyne becomes alkyl halide. All these two bonds break, and instead of that bromine adds when you add Br2. If you add Cl2, between these two carbon it remains a single bond, and replacing the other two bonds chlorine or bromine adds. So if you want to add 4 bromine, 4 chlorine or 4 iodine to a molecule, so what you should do is you should add halogen atom to alkynes. We have discussed in the previous videos also that when you want to add OH, the reagent you should add is KMnO4. 2 OH molecules can be added to an alkene when you add KMnO4. So here if I want to add 4 OH molecules to a compound, what should I do is putting alkaline KMnO4 to alkyne. What happens here is replacing one bond 2 OH binds, and replacing another bond another 2 OH bonds. So here keeping only one bond remain with these 2 carbon atoms, 4 OH attached to this compound. If I want to add H2O molecule to alkyne, what I should do is I should take the reagents diluted H2SO4, Hg2+, and I should supply a condition of 60 Celsius. Right? If I add H2SO4, diluted H2SO4, Hg2 plus and 60 Celsius condition is provided. What happens is replacing one of the bonds, one OH and H binds like this. Hydrogen goes to the place where with more hydrogen and OH goes to the place where with less number of hydrogen. So this compound is formed and it is known as enol. Enols are unstable. So we do not write the enols in organic conversions. It is unstable compound. Then what happens to this enol is it rearranges to aldehyde or ketone. This enol rearranges into aldehyde or ketone. So here the rearrangement happens like this. This carbon is the one containing hydrogen. So it gets a maximum number of hydrogen replacing this bond, and this hydrogen comes to here, right? And for this O, it becomes a double bond. I will repeat. This hydrogen comes to here and this O binds to this carbon with a double bond. So that is how the rearrangement happens. But you should remember that in organic conversions, we do not want to write this enol. No need of this. We should directly write the aldehyde or ketone formed by addition of diluted H2SO4 to the alkyne. So now I am going to teach you a direct method to write the aldehyde or ketone production method from the alkyne. What you should do here is you have to put the maximum number of hydrogen to the carbon atom with maximum hydrogen. So triple bond is between these two carbon. And if I name these as A and B carbon atoms, A carbon atom has no hydrogen directly bonded to it. And B carbon has one hydrogen. So the carbon with maximum number of hydrogen is carbon atom B. So I am going to give maximum number of hydrogen to it. It can bear 3 hydrogen, right? And for the other carbon, I am going to attach a double bond O. And this triple bond is no more there. Replacing that, there is a single bond, right? I will repeat the way. What you should do is, you have to identify the carbon with higher number of hydrogen. So from these two carbon, this is the carbon having the higher number of hydrogen. So carbon can have 3 hydrogen in this situation as the maximum number. So I am going to give 3 hydrogen to that carbon. And to the other carbon, double bonded O is attached. And this triple bond is no more there, replacing that there is a single bond. We will discuss about the acidic nature of alkynes with terminal hydrogen. First of all, we have to understand what terminal hydrogen is. So here, this carbon atom has a triple bond, right? And if I take another example, CH3C triple bond C, and to this CH3 is attached like this. These are 2 examples that we should consider. So if I take the electronegativity of this carbon, it has a sp hybridization and higher electronegativity. If I take the electronegativity of this carbon, this terminal carbon, that has sp3 hybridization, and due to this sp3 hybridization, it has a lower electronegativity. So comparing these two, this carbon has a higher electronegativity, so it attracts the electrons in this bond toward itself much. So due to that, there is more tendency for this hydrogen atom to leave. Here only 25 S characters are there, but here 50 S characters are there for this carbon. So the electronegativity is higher in this particular carbon. So it attracts the electrons in this bond. So this hydrogen has much tendency to leave. So this is considered as a acidic hydrogen or a terminal hydrogen. But in this case, you can see instead of this hydrogen, there was CH3 like this, right? That means here this hydrogen, in the terminal it has hydrogen, it is true, but it is not called the terminal hydrogen. The reason is that this carbon is not directly attached to the triple bond. The carbon which is directly attached to the triple bond is this. The carbon which we imagine here, is attached to a single bond, but this carbon is attached to a triple bond. If a carbon is attached to a triple bond directly, and for the same carbon if a hydrogen is attached, we call that hydrogen atom as a terminal hydrogen or acidic hydrogen. So here this one is a terminal hydrogen or acidic hydrogen. You should remember that point. Now we will move on to the reaction. These acidic natured alkalines react with active metals. So here in your syllabus we will talk about the reaction of these acidic alkynes with sodium and NaNH2, right? If this reacts with sodium, what happens is hydrogen leaves and CH3, C, triple bond C minus charge comes to here because the electrons comes to this carbon, and sodium plus attached to here, and it produces a byproduct, hydrogen gas, right? The ion formed here is known as alkoxide ion. The ion formed here is known as alkoxide ion. This is the reaction with active metal sodium, right? So if we write the reaction with NaNH2, what happens is this CH3, C triple bond C minus, hydrogen leaves and Na plus comes to here, forming the gas ammonia, NH3. We do not consider about the byproducts when we write the organic conversions. So do not focus on that byproduct. What we should think is about the alkoxide ion forming here. So I hope to discuss some organic conversions in with you within very near future.
Subscribe for more content.